Okay. So the first question, yeah. Social work number 4. This is test from 2020. Let's begin. We have to find volume of solid that is obtained by revolving the region x log n squared 1 plus x cubed, y equals to 0, x equals to about y-axis. Okay, so how we can solve exercises like this? First thing that we have to do is understand by which formula we are going to calculate volume. So here our region is some function is given. So we have some function actually that starts at 0. It is something like this. Doesn't matter. Y equals to 0 is x-axis, and x equals to 2 is something like this. So this region, we are revolving around y-axis. What is the volume of calculation of the volume when we are revolving shapes like this around y-axis? Could you please remind me how we can calculate volumes in that case? What is the formula? Guys, around y-axis region below function f.
It is 2 pi x
Then
top function minus the bottom function.
okay, now we have only one function, so no need to subtract. 2 pi x multiplied with f of x. So multiplying with f of x, we'll get here x squared logarithm squared 1 plus x cubed d of x. What about bounds of this integral? So we saw it is from 0 to 2. Okay, so first thing that we have to do, get the integral. Second, forget about volumes, areas, etc. Focus on the calculation of integrals. Now, x squared logarithm squared 1 plus x cubed. Do you have any suggestion how we can calculate this integral? So the trick is here, maybe we need to do some substitution, and 1 plus x cubed denoting by u will help. Moreover, having here x squared, definitely that substitution is very useful. So 1 plus x cubed denoting by u, derivative of 1 plus x cubed gives 3x squared d of x is our du. And we have x squared. We do not have 3. That's not a problem. We can multiply and divide by 3. So we'll get, let me put all constants out, 2 pi divided by 3, integral from 0 to 2. And we have logarithm u du. Logarithm u du. Because x squared d of x with 3 is du. And I have here logarithm squared. Okay. So it seems we have simplified our expression, but still integral log r squared is not obvious. And just before we continue, find my mistake, what I did here wrong.
I'm sorry, don't we have to change the boundaries
Yes,
for
I
the
did.
integral?
Yeah, when I said, yeah, what I did wrong, the answer, yeah, is taking care of boundaries. When x equals to 0, u is 1. When x equals to 2, u is 9. And now let's calculate the integral log r squared. Next, do you have suggestion how we can calculate integral log r squared? If no suggestion, do you remember how we are calculating in terms of just logarithm x? Just integral logarithm x, how we are calculating? You are right, integration by parts. But please unmute before answering. Unmute yourself. So we can just multiply with 1, and 1 is derivative of u times log r squared u du from 1 to 9. We are doing integration by parts, IBP. We'll get 2 pi over 3 times u log r squared u evaluated from 1 to 4, and minus 2 pi over 3 integral derivative of log r squared gives 2 times log u times the derivative of u. Derivative of u and the derivative of log u is 1 over u. 1 over u, and we have u from 1 to 4. So u will be cancelled with u, it remains log u. And how we can calculate integral log u? So initially we had log u, now we have just log squared, now we have log. The same trick, integration by parts. So when we plug 4 into our expression, we'll get 2 pi over 3, 4 times logarithm. 4 times logarithm squared 4 minus 1 times logarithm 0, which is 0, and minus 2 pi over 3. Now, integral logarithm, we are doing exactly the same step. Logarithm, we are multiplying with the derivative of u, doing integration by parts. We'll get u times ln u from 1 to 4, and minus integral of derivative of logarithm times u. So u over u, something like this. We have here this 2. Let's do not forget about this 2. Here we can put it as 4 over pi, 1 to 4, and we are done. It remains just to write u over u is 1. Integral of 1 is just here 3, and everything here is done. So the main maybe issue here was how we can integrate log r squared, and the answer is integral of log r squared we can derive by integrating by parts. Okay.
Why did we change the boundary like to 4 here? If it was like 9 to 1, 1 to 9.
Yeah, little by little, my 9 was transformed into 4. It should be 9. Everywhere it should be 9. Sorry. Okay. So It is 9 here. It is 9 here. It should be 9 everywhere. You're right. Okay. Questions about this exercise? If no, let's move forward. What was our next question? Multiple choice number 2 and number 6 from 2022. 2022 is this multiple choice number 2 and 6. So we are given a line and curve. Okay. So we have parabola x to the power 4, and we have line 8x. And this region is revolved around y-axis. How we can find volume? Actually, we just applied that formula. So that was 2 pi integral from 0 to this intersection point. Intersection point is a point where x4 equals to 8x. So if x equals to 0, yeah, we found it. If x is not 0, what is the other intersection point?
Oh,
Yes. X equals to 2 here. And we have x times the curve above, 8x, minus the curve below, x to the power 4. Am I right? We are revolving this around y-axis. So this is first attempt. Now let's see, do we have such answer? And we have 8x minus x4, but without multiplying with x. So A is not correct. Like, it's not the same as here. B is not the same. Same with, no, for C, we have, it's different, right? C, D, E. At first glance, we have something different. Let's do not panic. That was just the first attempt. If it doesn't work, what can we do next? Let me erase this part and discuss about the other approach. Moses, you have a question?
An image x verciu mazut grațele.
Why? We found it. As I said, no need to panic. Somebody will help us. So we have it. What I was thinking, guys, I was thinking maybe we should explore this, and now let's discuss it as well. Maybe the calculation. So it's finished, but one idea is the following, that maybe it can work if we have curve like this, and this region is revolved around y-axis. Also, volume can be calculated by pi g squared y dy formula. And if we have two such functions, we can subtract from one from the other one. In our case, the only point for that we can say it doesn't work is intersection point. Like when x equals to 2, y is 16. So integral is going to be from 0 to 16. Pi times curve on the right side squared minus curve on the left side. So we had base on the right side. It's squared. So here x is 4 to the root of y. So we'll get root of y minus squared of 8 y over 8. dy times pi. So yeah, if we have something like this, and actually here we have everything except this two. This two is not correct. Should be 16. And as Moses helped us to find this x written here, everything is correct. Questions? If no, let's move forward. And our next is number 6. From the same year. Okay, find the limit, and our initial reaction maybe is this is something wrong limits we have calculated during calculus 1, and this is calculus 2. Never we spend time on calculation of limits, but actually here the trick is L'Hopital rule. We can think of finding limit of ratio by applying L'Hopital rule. And what says L'Hopital rule? It says that if you have limit h tends to 0 of so we have h, I'm writing in this way, just rewriting all expression pi over 4 plus h sinus x over x. So a naive approach is to calculate the integral sinus x over x, then find limit, but we cannot integrate sinus x over x in terms of finite combination of elementary functions. So we are thinking another trick, yeah. Plug h0, we'll get immediately 0 over 0. Like integral is from pi over 4 to pi over 4, which is 0. H at 0 is 0. So 0 over 0 means we can apply L'Hopital rule. So calculating derivative of numerator divided by the derivative of denominator. Derivative on denominator we have h. Derivative of h is 1. And above, applying fundamental theorem of calculus, instead of x, we have to plug pi over 4 plus h. And divided by pi over 4 plus h. Multiplied with the derivative, and derivative is 1. So instead of h plugging 0, we will get sinus pi over 4 divided by pi over 4. Sinus pi over 4 is root of 2 over 2. So we have 2 root 2 over pi. And we have it here. Okay? So here the trick was L'Hopital rule. And calculation of derivative is not complicated if we remember about fundamental theorem of calculus. 2023 show work number 1. 2020. So work number 1. Yeah. Okay. Given region bounded by these curves, our goal is to calculate area of that region. Okay. First thing that maybe it worth to try to draw the graph of it. 3 times root of x. This is 3 times root of x. Y is 4 minus x. And this is 4 minus x. Y equals to 4 minus x. And we have x-axis. X-axis is here. So our question is to calculate area of this. Okay. How we can do it? If you find this intersection point, then area can be split into 2 parts. And if this is point A, and what is this point? This is point 4. Then area can be calculated by integrating from 0 to A, the first part, S1. S1 is just nothing else than just integral of 3 root of x dx. And S2 is the integral from A to 4 of 4 minus x. Okay. So, and the intersection point here is not complicated. Just to find it, 3 root of x equals to 4 minus x. Denote root of x by t. Root of x is t. We will get some second order equation, t squared plus 3 minus 4 equals to 0. And here we are going to get that x equals to 1. Actually, is the intersection point, but yeah. Discriminant is 9 plus 16, 5, 3 plus 5. So roots of this equation, t equals to 1 and t equals to minus 3. Minus 3. Am I right? T equals to minus 3. Minus minus 4. Sorry. So x equals to 1. X equals to 1 is the intersection point. Hence, yeah, we have from 1 to 4 very simple integral, from 0 to 1, 3 root of x. Again, obvious examples. So here the trick was to split domain into 2 parts. Now, question. Is it possible to calculate this area within only one integral? And the answer is yes, we can calculate only one integral. And remember, if we are given this type of region, its area is just integral of gy. So if we express everything in terms of y, like here, this is x equals to, since everything here we are going to talk about positive branches, it's y squared over 9, and here x is 4 minus y. We will have integral. Here at point 1 we have 3, so from 0 to 3 y is 3. From 0 to 3 our line 4 minus y minus this curve, which is y squared over 9 dy. And here we have only one integral. Okay, but I'm not sure that this is better than just calculating within x. Questions about this example? Okay. Do we have more questions on our chat? No. Guys, if you have questions, please do not hesitate and post your questions on this chat. So we have already covered 4 exercises. If there is not any further question, maybe we can continue solving a test that we started today during the class, which was the midterm from the last summer, where we I think we are here. And exercise number 9 says, given Riemann sum, our goal is to identify integral, which integral is given by this sum. Okay, what can we do? One approach, one step is having here 2, think of interval with length 2, A, B, D, E. And just as a reminder, if we have function f and we have a b interval, then Riemann sum is nothing else than b minus a over n if we have equal partition. This is length of each interval times f at xk minus 1 endpoint of left or right endpoint of interval, kth interval. Kth interval can be calculated by a plus k times. In our exercise we have I times. Let me write it as I times. Length again, b minus a over n. Okay, let's now discuss some options. If we are considering from 0 to 2 interval, a and b, this means that we have 2 over n. Okay, we have 2 over n. I'm just trying to write Riemann sum of function on 0 to 2 interval. Then f a equals to 0, so here we have 0. Now we are considering a equals to 0 case, b equals to 2 case. F I 2 over n. Huh? And which means, so this f I times 2 over n is going to be this one. So what is fx in this case? If f 2I over n is 2I over n cubed times cosine I over n plus 1. What is fx? How we can find fx? Just remember, 2I over n is our x. On the right side, everything replaced with 2I over n, which is x. So we'll get x cubed and cosine So what is I over n? It is 2i over n over 2, so x half plus 1. So one approach is to get here integral from 0 to 2, x cubed cosine x half plus 1. Do we have such answer? It seems that yes, we do. B seems to be the correct answer. Same way, exactly same way, we can assume like what if this 2 actually is not the length, but it is a part of our function, like here we have 2. And 2 is a part of our function, and 1 over n is the length. So let's discuss C is correct or not. If we have interval from 0 to 1, then Riemann sum actually is just 1 over n times f I over n. And in this case, this means that f I over n is 2i over n cubed times cosine I over n plus 1 times 2. This is fi over n. 1 over n is 1 over n. Everything else is fi over n. So in this case, what is f of x? F of x will be, so 2i over n is 2x. So 2x cubed times cosine x plus 1 times 2. So here it is not the correct answer B, since we have 2, not 8. It should be 8 to get the correct answer. Same way, if we consider maybe D's correct answer, how we can explore D? So if A equals to 1, B equals to 3, our Riemann sum will have the following form. Okay, 2 over n as length is 2, but f1 plus 2i over n, which means f2i over n is 2i over n cubed times cosine I over n plus 1. If 1 plus 2i over n is our x, then 2i over n will be x minus 1. Our formula will be x minus 1 cubed. Our function will be x minus 1 cubed. And what is inside of cosine? Inside of cosine, we have in plus 1, but 1 plus 2i over n is our x. If this is x, we have x half, x plus 1 half. Then the correct answer also is from 1 to 3, x minus 1 cubed cosine x plus 1 over 2 dx. And of course, we do not have this. And also, answer E we can discuss, and we'll see that it is not the correct one. So as we have seen already, B is the correct answer. Questions? If no question, let's move forward. And the next one is given parametric equation. Our goal is to find derivative at x minus 2. And how we are finding dy over dx, we just need to calculate dy over dx is derivative of y. So derivative of y gives exponential t plus t exponential t divided by derivative of x. And our goal is to calculate at x equals to minus 2. And we have only t, not x. So x equals to minus 2, we have to identify what is, in that case, corresponding t. So t cubed minus 3 equals to negative 2. T cubed equals to 1, t equals to 1. So we have to calculate this at t equals to 1. T equals to 1 gives numerator 2e divided by t equals to 1, 3. So 2e divided by 3. 2e divided by 3. Do we have such answer? None of the above. Huh? Okay. Can move forward. And then we have to calculate area of this region. How we can do it? By simply, if we split this integral into two regions, S1 and S2. And somehow we have to calculate this all intersection point. Here is A, here is B, and at the end we have here point C. Then our area can be calculated first from A to B. Our bigger curve is y equals to x. So x minus, what do we have below? Below we have this 4 over x minus 3. So this gives S1 plus S2. S2 is now integral from B to C. Again, curve above is x, but now curve below is 2x minus 10. And calculate, before calculating, integrals are straightforward, just polynomials. But finding A, B points, A, B, and C, sorry, important here, so intersections. For example, x equal to find A, we should have to calculate the intersection of x with 4 over x minus 3. And solve this, get that x is equals to 1. So here we are going to get 1. To find this intersection point means 4 over x minus 3 should be equal to 2x minus 10. Which means 4 over x is 2x minus 7, which means 2x squared minus 7x minus 4 equals to 0. We have to solve this equation to find the next intersection point. And then we'll see this intersection point. And actually, if we have two intersection points, we have to pick positive, because here we have given that x is positive. So solving the quadratic equation, discriminant is 49 plus 32. And then, yeah. Solve and find. I'm leaving you to calculate this constants. And the last one, intersection of two lines, x equals to 2x minus 10 gives x equals to 10 is here. X equals to 10 is the last point. Huh? Questions? And the integrals I have skipped because all were like standard examples. What do we have? 3 plus exponential x, 3 minus x, x equals to 0 and x equals to 1. So I did something wrong here in this picture. When x equals, so this is here is 4, here is 3. So we have this x equals to 1, 3 plus exponential. Okay, so this is our base. Cross sections are rectangles whose height is 2 times of the length of its base. So here, this is the base. And the height of rectangle is twice bigger. Okay, first question, what is the base? This base. This base is 3 plus exponential x minus 3 plus x. What is area of rectangle is height times width. So volume can be calculated by integrating from this point to this point, from 0 to 1. Area of rectangle, as we said, is 2 times exponential x plus x squared p of x squared. So opening square here, we'll get 2 times integral from 0 to 1 exponential x squared plus 2 times x exponential x plus x squared. Again, not so complicated. The only one that we have to maybe work a bit more is how to integrate 2x exponential x. And the answer is what? How we can integrate 2x exponential x?
IBP?
IBP, exactly. Exponential is derivative of exponential, and then the rest, is straightforward. So again, I'm leaving you to complete this exercise. Exercise number 3. Given some function, our goal is to calculate the equation of tangent line. And the equation of tangent line is y equals to f prime at 2 at x0 times x minus x0 plus value of function at 2. So here, to finish this exercise, we have to calculate f2 and f prime at 2. f2 is easy. Plugging 2, we'll get integral 2 squared minus, so 2 squared is 4, minus 8 plus 3. And below we have root of 4 minus 3 of something. So we have to integrate from -1 to -1 of something. And the integral from -1 to 1 is always 0. So f2 is 0. And it remains to calculate the derivative of our function, which is possible to do if we practiced a lot and we are familiar with fundamental theorem of calculus, which says f prime is what? Now, one of the issues is that here we have something dependent on x. That's fine, because we can take it out from the integral. So x squared minus 3x minus 1 times integral from root of 2x minus 3, x squared minus 4x plus 3, e t squared dt. So we have to calculate derivative of multiplication. Derivative of multiplication is derivative of x squared minus 3x minus 1 prime times some integral, which gives 2x minus 3 times integral. Again, if we plug x0 equals to 2, we are going to have the same boundaries. So from minus 1 to 1, we saw it already. So this term is going to be 0. And also we have case when x squared minus 3x minus 1 is multiplied with the derivative of integral. And derivative of integral is, according to the fundamental theorem of calculus, is exponential. Instead of t, we have to plug x squared minus 4x minus 3 squared times x squared minus 4x plus 3 derivative gives 2x minus 4. And similarly, minus e to the power of root of 2x minus 3 squared times the derivative of root of 2x minus 3, which gives us what? So 1 over root of 2x, and here we have to multiply with 2, and here we have to multiply with 2. Okay, then plug instead of x2, we'll get again root of 2x minus 3 is minus 1, so it remains just to calculate this. Questions? Volume of region when we are revolving fx around x-axis. The formula is pi times f squared. So pi times f squared is going to be 3 plus root x cosine root x divided by root x d of x. And we are going to integrate from x equals to 9 pi squared over 4 to 4 pi squared. How we can calculate this integral, guys? Do you have any suggestion?
Denote root of x u.
Exactly. Root of x denoting by u. Actually, 1 over 2 root of x is going to be du. And multiplying, dividing by 2, we'll get 2 pi 3 plus u cosine u du. And bounds of our integral when x is 4 pi squared, u is going to be 2 pi. When x is 9 pi squared over 4, u is going to be 3 pi over 2. Okay, and how we can calculate this remaining integral?
IBP.
IBP. Yeah. Cosine is derivative of minus sinus. So cosine we can write as derivative of sinus. u. From 2 pi, we'll get 0, 3 pi over 2, and minus integral of sinus u, which is minus cosine u. Okay? We have two more questions. On 2024. Multiple is number 6 and 8. It's given some function f of x is given some function g of y, and question is calculate second order derivative at pi. Second order derivative is the derivative of the first order, right? What is g prime? Fundamental theorem of calculus says it is fy. So what is g double prime? It is f prime. If we have point pi, then at pi. What is f prime? F prime now here is root of 1 plus sine squared to x times 2 cosine 2x. Plugging pi, our result will be sinus 2 pi is 0. So we'll get just 2 times cosine 2 pi. So 2. Enough? Six and 8, yeah? Find average value of function on some interval. How we can calculate average value? It's from 0 to 2. It's 1/2 times integral from 0 to 2 of f of x. So 1/2, 1y/2, because length is 2. We can simply calculate integral from 0 to 1 of 2x squared d of x, plus from 1 to 2, and on 1 to 2, our function is 2 minus x. One half integral of 2x squared gives 2x cubed over 3 from 0 to 1. And plus integral of 2 minus x gives 2 minus x squared over 2 from 1 to 2. 1/2, we have 1, we have 2, and minus at 2, we have what? No, 1/2 times here 4 and 1/2, something like this. What do we get? We get 1/2 4 over 2 plus 1 over 3, so we get 3 minus 3 over 2. So it gives us 3 over 4. And this is the 3 over 4. Okay, what is the next question? Next question is yeah, it is what problem first from today's quiz. It was some not so standard statement, but it says describe solid which volume can be calculated by integral. For example, from 0 to 3 to x sinus x d of x. And there are so many different approaches to tackle this exercise. For example, if we think of volume can be calculated if you have given some region revolved around x-axis as pi f squared x d of x, then we can say, okay, let's choose f as f function is square root of 2x sinus x. If we take square, we'll get 2x sinus x. And to get rid of pi, divided by pi. If f is this function, then f squared is going to be 2x sinus x over pi times pi. It remains just 2x sinus x. And domain is given from 0 to 3. From 0 to 3 here, everything is positive, sinus is positive. So we can say function fx, the region is bounded by function fx, x equals to 0, x equals to 3, y-axis, that region is revolved around x-axis. Or we can think about another formula like volume. If this region is revolved around y-axis is calculated by 2 pi x f of x. So we can say choose fx in a way that 2 pi x f of x is 2x sinus x. So we have 2, we have x. So our function f is sinus x over pi. In this case, 2 pi x sinus x over pi gives 2x sinus x. And we can say region is bounded by sinus x over pi from 0 to 3, revolving around y-axis. So there are this many and possibilities. Also, we can think of revolving some, not revolving, cross sections are given by some formulas, etc. Guys, we'll continue more review on Friday morning as well. So if you have questions, please bring your questions for Friday. Okay?